Hello friends, welcome to our channel. Let's have a look at today's daily challenge problem, most profitable path in a tree. In this video, we're going to explain how to use recursion to address this problem. So here we use recursion is largely due to the fact that the tree data structure is recursive. And in the coding session, so we're going to emphasize a trick, that is to use argument order in function to trace direction in undirected graph. So for this problem, I guess the difficulty point is digest the requirements of the problem, because the problem statement is sort of long. So here also you need to pay attention to the constraint. So due to time limit, I'm not going to go through all the problem requirements and the additional constraints or assumptions. So for the coding, so the structure will be the following. First, we're going to build a tree, and then we're going to write functions to trace if Bob can reach the root of the tree and the time it reaches each node. And secondly, we are going to do the same thing for Alice, but we need to notice that Bob and Alice essentially travels differently. So Alice is traveling from the root to a leaf node, and Bob is traveling from the current position to the root node, right? And in between, we're going to determine the maximum income for Alice. So that's actually the overall structure. So in between, I'm going to use example 1 as a demonstrating example in the coding. So now let's move the coding. So we are going to follow the structure. So first, build the graph. This is actually rather straightforward. So we can have a length of amount. So this will be the number of nodes, right? So now let's look at graph. So we can write graph as an adjacency list. So we can use collections, default, dict. So we can use a set to hold the neighbors. And then we iterate over the edges. So for uv in edges, right? So we are going to do graph u. So because here I'm using set, so I'm going to add v, meaning that v is in the neighbor of u. So it means there's an edge from u to v. So similarly, we have this, meaning that there's an edge from v to u. In other words, it's undirected or bidirectional. So that's the first part. So next part is to trace the travel of Bob in the tree, because Bob needs to travel from the current position towards the root node, that is 0. So because here we have a bidirectional graph or undirected graph, so we need to have a way to trace the direction. So this is the trick where the trick comes into play. We're going to use argument order to trace the direction in undirected graph. This trick can be very useful, not only for this current problem, but for general idea or general problems. So with that said, let me first initialize a Bob temp. So this will be, so I'm going to use float infinity times n. So meaning that Bob temp given a node, it means the temp Bob arrives at node. So that's it. So now we are going to write a function to either check how to from the node Bob at arriving, how to arrive at the node 0, and also we want to modify the Bob temp in order to record the temps. So here let's define this function and call it find Bob path. So here comes the trick. So here we know we need to trace the node, and now if we can also trace the previous of the node, then we actually give an orientation of the direction. So also the time it arrives. So here the order is not important, but you need to know in your mind, so which is the current node, which is the previous node, right? So now let me first write down this function, and then I'm going to make a function call so that you can get what we mean by what's the role of this function. First, if node equals 0, it means that Bob has arrived at the root node. Then we can set time. So Bob time as a node is going to be the time, right? Then we just return true. So this is one thing. So now we can look at the neighbors. For next in graph node. So then we need to trace direction. If next does not equal to previous, right? Then we are not going to repeat the previous one, or from U to V and then V to U. This is not what we need. We need to move forward, right? And then we want to find Bob path. So then the current node is next. Then its previous is the current node, right? The time should be time plus 1, right? So then if we, from the next, we can arrive at 0, then we can set the time for the current node. So Bob time is going to be node time, right? So with that said, we also need to do the return true. So otherwise, so its path didn't lead to the root node, so we're going to return false. So that's the function. So it actually has two effects. First, it's going to modify this list, right? This list is mutable, so we don't need to do a non-local Bob temp. But if you do it, it's okay, right? That's the one thing. Another thing is that also we return a boolean, indicating that if the path is going to pass a certain node here, given by this. So let me call this function first and find Bob path. So this is the original position Bob has. The previous we can write it just a -1 and time started from 0. Then we can print out this Bob time. So let's see. We're going to use, as I mentioned, using example 1. So here Bob starts at index 3. So here is 0, right? Then he can travel using 1 unit to node 1. So this is the 1. And then another time to node 0. So that's 2. So this path does not passing 2 and 2, 0, 1, 2, 3, 4. So at 2 and 4. So it's going to be still infinity. So that's the function. Notice that here the stop condition is node equals 0, right? The reason is that Bob travels from his current position along the tree path to the node. So next we are going to write this for eddies. So for this, first I'm going to initialize a maximum income. So I'm going to initialize it to be negative infinity, right? So because we are going to use max for comparison. So with that said, let's first write the function and then do some explanation. So find eddies path. So first we know we need to still use the trick to trace the direction. We need to at least 2 pieces of information. So the current node at its predecessor, that's the previous. And then we need to track the time. And also we need to follow the income, right? Because we want to find the maximum one. So then first, if time is less than Bob time node. So this means eddies arrives at the current node first. So she needs to open or get the income. So that is income is incremented by amount as a current node, right? Another case is time equal. So meaning that they arrive at the node at the same time. So by problem requirement, so we are going to half and half, right? Simultaneously arrive half and half. So we are going to do income increment the amount node over 2, right? So we don't need to consider the time when Bob arrives first, because Bob will do everything. Alice will not open or get some income. So that's the first thing. We need to first get the income. And then we're going to check stop condition. So the stop condition at the first is that we arrive at node 0 for Bob, but here is we arrive at a leaf node. So how to check the leaf node? First is if node does not equal to 0, and also the length of the graph at this node will be 1, right? So there's no just one neighbor, and this neighbor also not 0. So this is the leaf. So if we arrive at this leaf, so we can do comparison. So we can do max income equals max income and the current income state, right? And then we are going to return. However, there's a problem. So this is different from the first function. So here, find Bob path is modifying a list. So list is mutable, so we don't need to use the non-local keywords. But here, when we do maximum income, so maximum income is outside this function scope, and it's immutable. So we need to use non-local. So let me first do this. Non-local max income. So this way, within this function, we can do modifications for this immutable variable. So if you look at the two functions together, actually they demonstrate a lot of things, and especially how the arguments are passed in Python. Because Python is passed by reference. Therefore, you need to distinguish if a variable you are going to modify is mutable or immutable. If it's mutable, you don't need to do non-local keywords within the inner function. Otherwise, you need to do this. So this is the one, right? So now we are going to consider the neighbors, right? So for next in graph node, so if next does not equal to previous, because if it were previous, right? So we actually looping, right? So then we need to find Alice path, right? We do the same thing. Next, so for next node, its previous will be the current node, and the time is incremented by 1, and the income is the current income state, right? And then what we want to do, so that's the whole function. So what we want to do is call find Alice path. So Alice is originally at node 0, so we can still write some pseudo index or node. So the time is 0 and the income is 0. So this will modify the maximum income. Let me first print out this max. We can direct return because this also can be seen. So max income. Let's see. Node is not defined. Do you mean by node? Let's see which node. Yeah. Graph is not defined in 62. Graph. Yeah. Yeah. So if you look at this function, so I get the. So you can also simultaneously print out this. Right. So if you like, you can also actually get a time for Alice, so you can compare that. So that's the two functions. Now let me first comment this out in order to avoid output limit. So then submit. Yeah, it passes the generic cases. So now let me quickly summarize the video. So here we used recursion to address the problem. So I guess the key difficult point for this problem is to digest the requirements of the problem. So that's done. Actually, the functions and the coding are sort of straightforward. So that's the one thing. Another thing is that how the arguments are passed in Python function. So in Python, it's passed by reference. Therefore, you need to distinguish if a variable you want to modify is mutable or immutable. Sometimes in inner function, like in find Alice path, you need to non-local this max income function. Well, in the first one, because Bob time is a list which is mutable, you don't need to use non-local keywords in the function. This is the second point. So with that said, I guess that's it for the current video. If you found this video useful, you're welcome to share with your classmates and friends. So thank you.